Next, we want to talk about creating a box and whisker, or just sometimes just known as a box plot, for our data set in this data set with the 100-meter running times. And so we've looked at what does the dot plot look like. So, and we've talked about its variation. And another way, and we've talked about range, another way to look at if things are skewed one way or the other, or just to kind of look at a comparison of the two graphs. We can do this by creating a box plot. And your box plot comes from the 5-number summary. And if you recall, the 5-number summary includes the minimum, the first quartile, the median, the third quartile, and then we also need the maximum. And so we're going to get that by going to the spreadsheet again, to the Google Sheet, and we're going to do that for both of those sets of data. And then we're going to hand draw it and visually see that, but we're also going to look at it on Desmos. So if we go to Desmos, and again, we still have the information in Desmos for this. We do not need the standard deviation. So I'm going to, well, I'll leave it there for right now, but it's my Google Sheet. And so for the first set of data, so I'm just going to copy this first set of data and then go to Desmos. And again, if I want to, I can just edit by recopying that in, and you'll notice that all the numbers changed as when that happened, which is a really nice feature there. We don't have to go back and retype them all into, say, if we used a graphing calculator. So we don't need the mean in this case, but we do need the median, which is 10.135 or 10.14. So 10.14. Then we have the minimum is 9.92. The maximum is 10.38. The first quartile is 10.07. And the second quartile there is 10.195 or 10.20. So 10.195 will round to 10.2. Okay, so now I want to grab my second data set and copy that, and then edit my line 1. And now it's changed all those answers. So now we have the median is 11.02. And let's colors here. Just what was it? 11.02. And then the maximum is 12. The minimum is 9.89. The first quartile, 10.38. And the third quartile is 11.66. Okay, so now when we draw our graph, we got to start with a number line. And just gonna use a different color here for our number line. And so this is the times. And we need to go from about 9.89 to 12. So maybe we go from 9.5 and then 10, 10.5, 11, 11.5, 12, and 12.5. And then so I have 9.92, so that's approximately right here. And then 10.07 is just a little bit beyond it. 10.14 is just beyond that. 10.2. This is what makes up the box. So your box is these three values here make up your box. And then your whiskers are, I really scrunched that in. That should be 10.38. And then for our other one, we want 9.89. It's just before this. 10.38. 11.02. 11.66. And then 12. So again, our box is our middle three. And we can see once again that our our set 2 is much more spread out than set 1. Okay. The other nice thing about looking at, or when we had Desmos do, we can try and figure out based on the mean and the median whether the data set is skewed or not. So the mean in this case for the data set 2 is 10.98. So our mean is our mean for this one is 10.98, and our median is 11.02 and 10. So the mean is less than the median, and so if we go back to our picture, when the mean is less than the median, this graph is considered to be left skewed. And now if we grab, since we didn't grab the information the first time, just grab that information one more time. And I can delete all of this. And this is why we should write down all the information. This time, notice that the mean is 10.13, 10.14, so we would consider the mean and the median are essentially the same. So that means that the graph would be symmetrical. So the mean here was 10.13. And so now we're comparing 10.14 to 10.13. And so this data set would be considered symmetrical. This data set would be considered left skewed. Now, another nice thing about using Desmos here, we can just type in box plot and then put L1, capital L. So we know that that's, sorry, just L. And now it displayed this little box plot over here. And but we have the little zoom fit button. So if we click that, we can see it very nicely. We want to, when we're working with when we're doing just our box plot, we want to uncheck the exclude outliers so that we can see the outliers there. Now, if I want the other data set, so this was data set number 1, and I'm going to define another list and grab my data set again for the second set of data. And I want a box plot. I'm going to just type box plot. Oh, or I can find it if I go under functions again, show you that. This time we want to go to visualizations and you'll see box plot there. And so box plot, this time we want M. And notice it's right on top of each other, but I want to zoom this one so that they're together, but I'm going to hit the I'm going to change the offset to 5, or maybe, let's see if that's, now I want to kind of zoom out a little bit. And so now maybe I don't want 5, let's go maybe 3. And so now they're on top of each other, or sort of on top of each other, and you can see them in terms of one on top of the other and kind of compare them that way as well. So we talked about, well, there's three different types of standard deviations, and a sample standard deviation is going to be the one that my math lab wants you to use. And that's a sample standard deviation. That's when you're just working with a sample of the data. When we talk about the population standard deviation, that's when we're going to use the normal curve, which is in our next set of notes. Also, the standard deviation for my math, or the symbol for standard deviation, if we go back to the notes, it's just that SX, and then sample standard deviation is actually the lowercase sigma Greek letters. So this is SX in calculator, and then it was when we typed it into Desmos, you recall it's STDEV. Or STDEVP. These are also some of the ones that Excel uses. The approximate standard deviation is just a quick little way to see how spread out the data is. And this time, we're going to take the range and divide it by 4. So once you find the range, and again, the range is the maximum minus the minimum, so this would be max minus minimum divided by 4 gives us the approximate standard deviation. And standard deviation is the spread outness, or how spread out the data is. Instead of in terms of a box plot, we're doing it in relationship to the median. In a standard deviation, it's the spread outness in relationship to the mean. And so if we look at the standard deviation for box plot, or for the first set of data, so that was my L data, this is talking about this is 0.12 seconds. Seconds? Or was that minutes? I think that was seconds, was it not? Let's go back here in seconds, yes. So this is 0.12 seconds. That's how spread out the data is about the mean. Whereas if we look at the second set, and if we do the standard deviation of the second data set is 0.72, so that's means that that's 0.72 seconds. So that's a lot more spread out. There's a lot more, let's call it wiggle room, in data set number 2 versus data set number 1. This is saying that this is very closely compact around the mean, and where this is less compact around the mean. So that's the difference between standard deviation in terms of when we're talking about, or what standard deviation is spread outness around the mean, whereas when we just look at skewness, or when we just look at variation, we're talking about, and these dot plots, we're talking about more about the median rather than the mean.